Welcome to our channel. Today we're diving into the fascinating world of solar flares and their bizarre effects on Earth. Our sun isn't just a giant ball of light and heat, it's a dynamic star capable of unleashing powerful bursts of energy with mind-blowing consequences. So buckle up as we explore the science behind these stellar explosions, their impact on our planet, and what the future holds for understanding these powerful events. Picture this, a massive explosion on the surface of the sun, releasing as much energy as billions of atomic bombs detonating simultaneously. That, my friends, is a solar flare. These flares originate from highly magnetized regions on the sun called active regions. Think of them as giant, twisted rubber bands of magnetic energy. When these rubber bands snap and reconnect, they unleash an incredible amount of energy in the form of light and radiation. We're talking about a sudden, intense brightening across the electromagnetic spectrum, from radio waves to X-rays and even gamma rays. It's like the sun suddenly decides to crank up its brightness knob to 11. They hurl massive amounts of charged particles into space at incredible speeds, sometimes approaching the speed of light. We call this solar wind, and it can have some pretty interesting effects on anything in its path, including our little blue planet. The intensity and speed of the solar wind increased dramatically, and this can interfere with our technology in some pretty surprising ways. But more on that later. So we've got these powerful solar flares blasting out radiation and charged particles. What happens when this space weather collides with our technology, specifically the satellites orbiting our planet? Well, imagine you're trying to have a conversation in a crowded room and suddenly someone cranks up a loudspeaker to full blast. The increased radiation can interfere with their sensitive electronics, disrupting communication signals and even causing temporary blackouts. And it's not just communication satellites that are affected. Navigation satellites, like the ones that power our GPS systems, can also be thrown off course by the increased solar wind density. This can lead to inaccurate positioning data, which might not be a big deal if you're just trying to find the nearest coffee shop. But it can be a major issue for airplanes, ships, and other vehicles that rely on precise navigation. In extreme cases, solar flares can even damage or destroy satellites altogether. That's why space agencies and satellite operators constantly monitor solar activity, using sophisticated forecasting tools to predict and mitigate the potential impacts of solar flares on our space-based infrastructure. It's a constant game of cat and mouse, but it's crucial for ensuring the reliability of the technology we've come to depend on here on Earth. Can solar flares really affect us down here on Earth? The answer is yes. Charged particles can induce powerful electrical currents in power lines. The result can be catastrophic. In 1989, a solar flare caused a massive blackout in Quebec. Scientists are developing new technologies to protect our power grids. By understanding the science, we can keep the lights on. The Northern Lights, nature's dazzling light show. So far, we've focused on the disruptive and potentially destructive effects of solar flares. But these powerful events can also create something truly breathtaking: the auroras. You've probably seen pictures of these shimmering curtains of light, often referred to as the Northern Lights or Aurora Borealis in the Northern Hemisphere, and the Southern Lights or Aurora Australis in the South. When charged particles collide with atoms in our atmosphere, they excite those atoms, causing them to release energy in the form of light. The different colors of the auroras are determined by the types of atoms being excited. For example, green auroras are produced by oxygen atoms, while nitrogen atoms can create blue or red hues. The intensity and location of the auroras depend on the strength of the solar flare and the orientation of Earth's magnetic field. During particularly strong solar storms, the auroras can be visible much farther south than usual. The next time you see a picture or video of the auroras, take a moment to appreciate the awe-inspiring forces at play. A cosmic dance between the sun and Earth. Space hazards, solar flares, and astronaut safety. Here on Earth, we're relatively protected from the most harmful effects of solar flares thanks to our planet's magnetic field and atmosphere. But what about astronauts venturing beyond Earth's protective embrace? For them, solar flares pose a significant health risk. Space is a harsh and unforgiving environment, and exposure to the intense radiation from a solar flare can be extremely dangerous. Astronauts caught outside the International Space Station or on a mission to the Moon or Mars during a solar storm could receive a lethal dose of radiation in a matter of hours. This radiation can damage DNA, increase the risk of cancer, and cause acute radiation sickness, which can be debilitating or even fatal. The International Space Station, for example, has a designated radiation shelter where astronauts can take refuge during a solar storm. Future missions to the Moon and Mars will likely require even more robust radiation shielding and early warning systems to protect astronauts from the hazards of space weather. Predicting the sun's fury space weather forecasting. We've talked about the potential impacts of solar flares, but how do we know when these events are going to occur? That's where space weather forecasting comes in. Just like meteorologists forecast the weather here on Earth, space weather forecasters use sophisticated tools and models to monitor the sun's activity and predict solar flares. They track things like sunspots, which are cooler, darker regions on the sun's surface that are often associated with solar flares, and coronal mass ejections, which are massive eruptions of plasma and magnetic field from the sun's corona. By analyzing data from telescopes, satellites, and other instruments, space weather forecasters can issue alerts and warnings about potential solar storms, giving us time to prepare and mitigate the risks. These forecasts are crucial for a wide range of industries and organizations, including airlines, power companies, satellite operators, and even government agencies. Airlines might reroute flights to avoid polar regions during a solar storm to reduce radiation exposure for passengers and crew. Power companies might adjust grid operations to minimize the risk of blackouts. As our reliance on technology grows, so too does the importance of accurate and timely space weather forecasting. Lost in space solar flares and GPS disruptions. In today's hyper-connected world, we've become increasingly reliant on GPS technology for everything from navigation to communication and even financial transactions. But what happens when solar flares interfere with these signals? As we discussed earlier, solar flares can disrupt satellite communications, and GPS satellites are no exception. The increased radiation and charged particles from a solar storm can interfere with the signals these satellites transmit, leading to inaccuracies in positioning data. Imagine your GPS telling you you're on one street when you're actually a block over, or your car's navigation system guiding you in the wrong direction. While these minor inconveniences might be frustrating, they can have more serious consequences for industries that rely on precise GPS timing and positioning. Financial institutions rely on GPS for accurate timestamping of transactions, and disruptions can cause chaos in the markets. Researchers are constantly working to develop more robust GPS systems that are less susceptible to solar flare interference. This includes things like using multiple frequencies to transmit signals and developing algorithms to filter out noise and interference. Solar flares have been erupting for billions of years, impacting Earth in remarkable ways. One famous event is the Carrington Event of 1859, observed by Richard Carrington. It caused telegraph failures and auroras as far south as the Caribbean. In 1989, a solar flare caused the Quebec blackout, showing our grid's vulnerability. Studying past events helps us prepare for future solar storms. Solar flares are incredibly complex phenomena, but scientists have made significant strides in understanding these powerful events. So how do we study something that's 93 million miles away and capable of releasing as much energy as billions of atomic bombs? Well, it takes a combination of ground-based observatories and space-based telescopes, all equipped with sophisticated instruments to observe the sun across the electromagnetic spectrum. Ground-based observatories like the National Solar Observatory in the United States use specialized telescopes to study the sun in visible light, providing detailed images of sunspots, solar flares, and other surface features. Space-based telescopes like NASA's Solar Dynamics Observatory orbit above Earth's atmosphere, giving them an unobstructed view of the sun 24/7. SDO captures high-resolution images of the sun in multiple wavelengths, allowing scientists to study the different layers of the sun's atmosphere and track the evolution of solar flares. By combining data from these various instruments, scientists can piece together a more complete picture of solar flares, from their initial formation to their eventual eruption. The study of solar flares is an ongoing endeavor, and there's still much we don't know about these powerful events. However, scientists are constantly pushing the boundaries of our understanding, developing new technologies and techniques to unlock the sun's secrets. One area of active research is improving our ability to predict solar flares. While we can currently forecast these events with some accuracy, there's always room for improvement. Scientists are working to develop more sophisticated models that take into account the complex interplay of magnetic fields and plasma flows in the sun's atmosphere. Another area of interest is understanding the mechanisms that trigger solar flares. While we know that magnetic reconnection plays a key role, the exact details of this process are still being debated. By studying solar flares in greater detail, scientists hope to develop a more complete theory of how these events are triggered, which could lead to more accurate predictions. The study of solar flares is a fascinating and challenging field, but it's one that has profound implications for our technological society. Thanks for watching. If you enjoyed learning about these bizarre science facts, don't forget to like, subscribe, and hit the bell icon for more amazing content. From disrupting our technology to creating breathtaking auroras, solar flares are a powerful reminder of the sun's influence on our planet. But they're also a testament to human ingenuity and our ability to understand and adapt to the challenges of the cosmos. Keep exploring, keep questioning, and keep looking up. See you next time.